Today, let's learn about potential energy. So, what is potential energy? Potential energy is the energy an object has because of its position or condition. In other words, it is stored energy. Energy that isn't being used yet, but has the potential to be released. You'll find potential energy in many everyday situations, like when you stretch a rubber band before letting it go, known as elastic potential energy. When you charge a battery, it stores energy that can later be used to power a device, known as chemical potential energy. When splitting or fusing atoms, such as in the case in nuclear power plants, this is nuclear potential energy. And of course, when a roller coaster sits at the top of a track, this is known as gravitational potential energy. In this video, we will focus on gravitational potential energy. So, we can describe gravitational potential energy, the kind related to height, with this formula: potential energy is equals to mass times gravity times height, written as PE is equals to m times g times h. This tells us that the mass or m of the object matters. Heavier objects store more energy. The height or h is also important. The higher an object is, the more energy it can release. The gravity or g, that is acceleration due to gravity, has a value of 9.8 meter per second squared on Earth. Like all energy, potential energy is measured in joules. Now, let's explore this more with a few real-life examples. Imagine you are in a quiet library, reaching up to return a small book to the top shelf. As you stretch your arm and lift the book higher, something important is happening. You're increasing the book's potential energy. Because you're changing its position, the book gains potential energy, the energy stored due to its height above the ground. Now, let's say the mass of the book is 0.5 kilograms, and you lift it to a height of 3 meters. What is the potential energy of the book in that position? To calculate for the potential energy, we can use the formula: potential energy is equals to mass times gravity times height. Let's substitute the given values. So we get PE is equals to 0.5 kilograms times 9.8 meter per second squared times 3 meters. And what's the potential energy of the book? That's right, it is 14.7 joules. So the book stores 14.7 joules of potential energy at a height of 3 meters. If it were to fall, that stored energy would be converted back to kinetic energy as it drops. Picture a bodybuilder at the gym, standing in front of a heavy barbell. As he grips it and lifts it overhead, he's not just showing off his strength. He's also increasing the barbell's potential energy. Let's say the barbell has a mass of 50 kilograms, and he lifts it to a height of 2 meters above the ground. How much potential energy is stored in the barbell at that point? To solve for this, let's use the formula: PE is equals to mass times gravity times height. Now, let's substitute the given values. So we get PE is equals to 50 kilograms times 9.8 meter per second squared times 2 meters. And what's the final potential energy of the barbell? That's right, it is 980 joules. So, by lifting the barbell, the bodybuilder gives it 980 joules of gravitational potential energy. Let's think back to the start of the roller coaster ride from the last video. Before the thrill begins, the cart slowly climbs to the highest point of the track. It pauses for just a second before dropping. At the top of the track, the cart isn't moving fast yet, but it holds a huge amount of potential energy because of how high it's been lifted. Let's say the mass of the roller coaster cart with passengers is 500 kilograms, and it reaches a height of 20 meters at the top of the track. How much potential energy does it have at that point? To calculate the potential energy of the roller coaster ride, let's use the formula potential energy is equals to mass times gravity times height. Now, let's substitute the given values. So we get potential energy is equals to 500 kilograms times 9.8 meter per second squared times 20 meters. And what's the potential energy? That's correct, 98,000 joules. So, at the peak, the cart stores 98,000 joules of potential energy. Once it drops, that energy is transformed into kinetic energy, powering the twists, turns, and speed that make the ride so exciting. So, what have we learned today? In this video, we explored potential energy, the energy stored in an object because of its position or condition. There are different types of potential energy: gravitational, from an object's height above the ground; elastic, from stretching or compressing; chemical, stored in batteries, food, and fuels; nuclear, stored in the nucleus of atoms. We also learned that gravitational potential energy depends on three things: the mass of the object, the height above the ground, and the gravitational acceleration, which is 9.8 meter per second squared on Earth. We can also calculate the potential gravitational energy of an object using the simple formula: potential energy is equals to mass times gravity times height, or simply written as PE is equals mgh. Thanks for watching. Like and subscribe for more videos coming soon. And that's it for today. See you next time and stay curious.